Okay, so we're going to do horizontal transformations. Okay, so we said the other day the only thing you've been working on right now is just vertical stuff, right? With the exception of the horizontal translations. What's going to happen today now is we're going to start horizontally stretching and compressing these graphs, which is going to change the period, which is what you see in the box there. So what's in the box, right, controls or shows you how to find the actual period, right? Or what the k value is. That belongs in the equation. So they do both things, which is why you see both versions there, right? So you'll see k. K is actually going to be equal to the 360 degrees divided by what the period is supposed to be. That's going to be the k value. And then the period, if you wanted to know if the question was asking how long does it take to complete one cycle, you're going to take the 360 degrees and divide it by k. Okay, and all they're doing is multiplying both sides by p and then dividing by k, or vice versa, right? So the period is the horizontal distance of one cycle of the function. A basic sine or cosine function has a period of 360 degrees. Okay, and if we consider a period of 720 degrees, this means that one complete cycle must happen between 0 and 720 degrees. Okay, so if I label my axes here, let's see if I can count this out right. 90, 180, 270, 360. Another 90 makes 450, 540. It's perfect. Okay, so we're going to graph y equals sine x, right? 2 cycles. Okay, and we're going to see what happens. Oh boy. Yeah, we're good. So here's one. Oh, we got to put the y-axis on too. Okay, I think we're good. Okay, so there's the graph, 2 cycles of the graph y equals sine x, or sine theta. That's ranging between +1 and -1. Okay, and then we're going to say what happens to that graph based on what I see in the equation there, Gabe.
It's going to horizontally stretch by a factor of 2.
Yeah. Okay, so we're going to get, this is a horizontal stretch by a factor of 2. Right, so if I wrote out my mapping statement, that should turn into the x values are going to be multiplied by 2, and the y values are going to stay the same. Okay, so that means the 0 is going to stay at the 0, the 0, 0 point. The 91, that x value now has to get multiplied by 2, right? So instead of being at 90, it's going to be at 180 degrees now. Okay, so we're basically taking all these points. We're not going to be able to draw 2 cycles on here, but you'll see the difference, I suppose, right? So this is going to go to here, and then the 180 is going to go to 360. The 270 goes where? If I multiply it by 2, 540, right? And then the last point, what would have been at the 360 is going to go to 720. Yeah, we're not going to have room to draw 2 cycles for this one.
But you can just rearrange the axes and make 90 degrees instead.
You could just shuffle it, yeah, from the initial bit, yeah. I wasn't thinking of that when we started. Okay. These are hard to draw without seeing where I'm going. Okay, so there's one cycle there. Is it okay? If something takes, let me ask a question. The blue one take longer or shorter to complete one cycle? Does it take more time or less time for that blue one to complete one cycle? Owen?
Longer.
Takes longer. So if this is a musical instrument, what do you think would happen to the pitch? Be sharper or flatter? Jacob? It'd be flatter, right? Because you're getting less cycles per second. So less hertz, which means it's flatter. Okay, it's taking longer to complete one cycle. Okay. Okay, let's go to the next one. Okay, we might have to think about how we're counting here, because we're going to, if I were to describe this, what would this be? Yep.
Horizontally compressed by a factor of 1/3.
Yeah, this would be horizontally okay. Mapping statement, what do you think happens?
1/3 x y.
Yeah. Okay, so we just got to figure out, maybe we can collaboratively come up with what we're going to count by, what our scale is going to be on the x-axis for this one. So we got to be smart about it. The other one might not be bad, actually. If we count by every 3 boxes is 90, I think that actually would be kind of nice. And we might actually, for this one, we'll actually be able to draw a couple cycles of this one because we're going to compress it. So we'll just do the same axis from the last question, because I know when I cut 90 into thirds, what do I get? 30. So if I count by 30s, I should be okay. Ever see what I mean? So the same scale as last time. 90, 180, 270, and 360. Okay? I'll draw the original cosine question, right? Which, for those of us who maybe didn't get that right on the quiz, now's your chance to look at it again. Oops. Okay, so cosine curve, the original cos graph, starts at 0, 1, it's 0 at 90, -1 at 180, 270. Okay, and then I'll just draw the, well, okay, so we can draw 2 cycles. This will come back down. Okay. Try to draw that. Okay, and sorry, when we draw these, make sure you're labeling them. We didn't do that on the last question. Okay, so now all those points, all those red points, whatever their x value is, needs to be cut into a third. Okay, and what we've done a nice thing with the scale here in counting by like 30 degrees for each box, right? Because now I can cut them into thirds. So 90 is going to go to 30. 180 is going to go to what? 60, right? And 270 is going to go to what? Okay. Did we get it? That's why the mapping statement's helpful for these, right? Because it keeps track of everything that's going on in there, right? And you can take your original points, substitute them into the mapping statement, and produce a graph. I think the mapping statement's even more powerful for questions like this versus the ones we did at the beginning of the course, because the scale, the x-axis is so much bigger in scale, right? So take the original x values and cut them into thirds. So 0 is going to stay at 0, the 90 is going to come to here, 180 is going to go to 60. And you could probably from that point on figure out what's happening, right? Okay, so that's actually, oops, did I do that right? No. That's actually 2 cycles there. So that's y equals cos 3x. Okay. What were the questions I asked you last time? Longer, shorter to complete one cycle. Takes less time to complete one cycle. Which, if this is a musical instrument, what happens? Becomes sharper, right? Because you're getting more cycles per second, which is defined as a hertz, right? And so if you increase that number, you're receiving, your ears are hearing more cycles per second. Hence the pitch goes up, sharper. Okay? Are we okay? This looks different for a whole bunch of different instruments. But temperature would be one. Temperature is going to affect how excited the molecules are in the air, and subsequently how quickly the wavelength is able to transfer its energy through the air. So higher temperature, wavelength's able to like move through the medium faster, the pitch is actually higher for what your ear is registering. The source vibrates at a frequency, but its ability to transfer through the medium in which it's doing is actually higher because the temperature is warmer. And vice versa is true if the temperature is colder, the pitch goes down. Pressure, like in my instrument, if I apply more pressure, I force more air across the reeds, they vibrate faster, pitch goes up. If I get moisture on the reeds, moisture causes, it's like a more mass on the tongues. Tongues vibrate slower, pitch goes down. So all three of those things are happening at once with my instrument. Pressure, temperature, moisture. Okay, and it's a big game of getting 30 people to match at the exact pitch for every single note for an extended amount of time. That's the game we play. It's down to a science. Some people have figured this out pretty intensely. Anyway, are we good? I can model everything I'm doing with trig and sine waves, okay, or periodic functions, okay? A little tougher this one, okay? Again, I would think about what you're going to count by. If you're going to count by 30s, I think 30 is going to hit that 120, so that's still not a bad one to count by. You also have to cut this in half, which is going to be a little tricky, I think, because half of the 90 that we were talking about is going to be one box, or 1.5, so 45 degrees, right? So that's going to be a little trickier to cut that in half. Okay, so sometimes these questions get a little bit messy depending on how you choose to label your axes, right? So just got to be a little clever. Think about what's happening. That's maybe why we'll start here with the the mapping statement and what's happening. So let's talk about what's happening to this graph right out of the gate. So you've got the original cosine curve. What has to happen to the original cosine curve? What comes from left to right? What are you seeing? First transformation. On.
Horizontally stretched right there.
Yeah, it's horizontally stretched. What we'll do is we'll stop here after this one. You guys can try the last one, and then we'll take it up, okay? Okay, and then what? Gabe?
Horizontally translated right 120 degrees.
Okay, so if I do say draw 2 cycles, you also got to be cognizant of how you're counting in order to make sure that you can get 2 cycles on your grid. Okay, so maybe this time. What do you want to do? Gabe, what do you want to do?
Make the parent graph right.
Yeah, but in order to draw the parent graph initially, I'm gonna have to label my x-axis. Or I suppose my question was, what am I gonna count by here? In order to make sure that I'm able to draw 2 cycles on my grid. Knowing the graph has to be multiplied by 2 horizontally, which means 1 cycle is now gonna take 720. And it also has to get moved to the right 120 degrees. So we might not be able to get, I don't know, we'll see. Jacob?
Do like every other line?
By counting by what though?
Still 90s.
So 180.
Maybe, but yeah.
Like you're saying every line is 90 degrees.
Yeah.
Is that what you're saying?
Yes.
Yeah. So like 180, 360, what's the next one? 720 would be the, this is 540. Okay, let's just draw cosine, get it out of the way. Okay, the parent graph. I also got to label. Oh, mapping statement. What are we gonna say for the mapping statement before we draw this thing? Okay, you'll notice today we're not touching Y at all. That's what you've been supposed to have been doing for 2 days, right? Is stretching the graph vertically, moving it up and down. Okay, what do you think tomorrow's gonna be? You're gonna have all of them in there tomorrow, right? Tomorrow's just gonna work on graphing these questions, right?
You're not
You-
gonna transform to n over.
I'm not gonna really get you into do tan, I don't think.
No, I don't know.
Okay. So let's graph the original cosine. 2 cycles. Okay, that's y equals cos x. And then what? You want to do this in 2 bits? So these all have to get multiplied by 2, right? And then shuffled. So what we could do too, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is going to be what? What degree? 720 times 2. What's that? Gabe?
1,440.
That's right. Okay. So that would represent, if I continued that red graph, that would be 4 cycles of the graph to get to 1,440. Okay. And when you don't do this for a while, or you're seeing it for the first time, these are a little, like, it takes a bit of time to draw the axes, right? And scale them appropriately. That's not easy. Okay, but again, that's a skill that I work on with the grade 9s, right? So that's just something you continue to, like, refine through school. Okay, so let's do the horizontal stretch first. We'll take all those points and double them. Okay, so the 90 is going to go to 180, 180 is going to go to 360, so on. And the 720 is going to go all the way down to 1440. They're okay? All right. So that's all I'm going to do here for a second. And then we'll take everything and shuffle them all over 120 degrees. Whatever, that one might be a bit of a guess based on how we've labeled our axes. Okay, so 0, that's going to stay there. That's going to go to there. 180 is going to go to 360. 360. Oh. You also, okay, just so everybody's good, you can also forget about the degrees on the axis and just count boxes. Does everybody know what I mean? Like this box is 1 away. If I take 1 box, multiply it by 2, it's got to be 2 away. So you can take each point and just multiply it by 2, how far away it is from your y-axis, instead of dealing with the degrees. That's also 100% fine. Okay, because I will be the first to admit, I'm having a hard time keeping track of the points, especially when they're not labeled on the axis, right? Okay, so just, you can count boxes as well. Like this one here is 3 boxes away, so now it's going to go to 6. You can do these in order, right? Next one is 4. So it's going to go to 8. Next one is 5. It's going to go to 10. By the time you get to here, you should start seeing the pattern though, right? That's a better way to do it, I think. Just count the number of boxes relative to your y-axis. It's a better way to do it, instead of trying to keep track of all those degrees. Okay, so now I'll connect those. This is still 2 cycles of this graph, right? Okay, now you got to figure out where's 120 degrees on your axis. Like how many boxes?
1.5.
Yeah, I think this was actually a really nice scale, because 120 is exactly halfway between 90 and 180, right? And so we're going to count by 1.5 boxes. Okay, because this right here, if everyone can see, let's see if I can get a different color. That's 120 degrees. So I need to shift my graph by 1.5 boxes, all points. Okay, so that means this one goes to here. Okay, and you're doing the blue points, not the red ones. Come on. Everyone good?